Testing the mic. Okay. If you can hear me, say so in Slack. Although I also do have the YouTube chat up, but I'm not looking at that right now. Oh, uh-oh. And the camera's not on. And you see me now? Oh boy. Hold on, everybody. Okay, there. Now at least you're seeing the laptop. Oh, there I am. Okay. I have a problem, which is that the mic clip that I usually use, this new mic clip that I paid like $3.79 for or something on Amazon, is broken. So I have found this other mic clip that's not really meant for this, but maybe it'll work. Although in theory I could string this through. Let me take my glasses off for a second because I'm very nearsighted, so this makes it easier to look at. See if I can get this in there. I don't want to break it though. All right, I'm just going to do this probably the tape way. Yeah. Okay. I'm going to just tape this. So hopefully, sorry for the extra noise that's currently happening. So while, I don't know how well you can hear me because I'm futzing with the microphone, but so this is the thing, like sometimes I feel like I would like to just quickly spend a half an hour doing some additional recording for like a video that was made, but it's starting to feel like a big to-do to do the whole full like public live stream thing. So I thought I would try this as an experiment, plus it's an added benefit if it's something people enjoy for people who are patrons, and I can also answer specific questions, or we can have kind of discussion. I don't know, we could even do like people calling in at some point. So let's see how that goes. I'm taping this here. Hold on. I'm taping the microphone. Okay, well, come on, microphone. Stay on. I'm so mechanically challenged. Okay. So I've now taped the microphone onto this clip. Sorry if this makes some weird noise. I'm going to pass this through my sweater. A little behind the scenes here. Of course, I do this anyway. Oops, and now of course the tape came off. What if I tape it a little bit more firmly? By the way, I'm not looking at the YouTube chat if people are chatting there. I don't know what is a better, people would prefer to use the Slack channel or the YouTube chat during these member-only streams. There we go. Okay. I wonder if I order some new mic clips on Amazon right now, if they will get here by Wednesday. By the way, look at this. All right, so I'm really here to do one thing and one thing only. I'm hoping this will take less than an hour maximum. And in order to get started with this, I need to actually pull up, oh, that's good, I'm gonna need this. I need to pull up, let's see, can I go into my Creator Studio? Let me just turn this. It's possible that I would publish these videos later. So what I'm doing right now is I am signing in to my YouTube account. And attempting to pull up, time to do some two-factor. Where's my phone? Oh, here it is. It's weird. It's almost as if nobody's watching this. I'm so used to like stuff going by in the chat constantly. It might be that nobody's watching this. Two-factor. and then Creator Studio. Here we go.
Hello, welcome to part 2 of
Okay.
the polar Perlin noise loops. I wrote polar noise loops on purpose as like a wordplay thing. And people kept saying, no, it's Perlin noise, yes, polar Perlin noise loops. The whole point of this is I'm doing a follow-up of my previous coding challenge where I made this blobby shape, which is created with a Perlin noise algorithm, and the end of the shape.
Okay, so what I just want to watch this.
Walking through a two-dimensional Perlin noise.
I just want to watch this until about minute 6. I've got a 1.5 speed, so it's going to take. This is the edited version that Mathieu put together of the follow-up to the noise video that I put out today. So I want to just sort of find the point where I want to stop and pick up from. So.
Space in a circle. If you're wondering what I'm talking about, go and watch the previous video, but also I forgot in the previous video and neglected to show this particular sketch created in P5.js by Golan11, which demonstrates this idea. So the idea is I want to use Perlin noise values over time, but I want the last value to match up with the first value. And so if I pull those values from a circular path, and in truth it doesn't have to be circular, as long as I end up where I started, then I'm going to have this perfect looping Perlin noise. So why not take that perfect looping Perlin noise and apply it to my GIF loop, so that I can, in the GIF loop coding challenge, I just had this rotating circle. It's very easy to have the end match up with the beginning. But what if what I want to create is random, chaotic, algorithmic scenes of beauty? And an example, an artist who does this is Etienne Jacob. And you can read more about this work at necessarydisorder.wordpress.com. This is a blog post from November 15th, 2017. You can find many more of these like amazing GIFs on Etienne's Twitter account, all of which I will link to in this video's description. So this video is inspired by the beautiful work, and this is mind-blowing to me. This is not a sketch running over time. It is a perfect loop, yet it seems as if it's just continuous random chaos. So let's go back to all this stuff. So what do I want first? So one thing you might have noticed is in the previous video I was working in JavaScript. I have now moved over to Java using the processing development environment. This is mostly because what I want to do now is render files out that I can then repackage into a GIF. You can do that in JavaScript too, but I haven't found like a really excellent, elegant solution for doing that yet. So when I'm working with rendering, I generally prefer to be in processing. And also I like to just show you different things. So
I'm going to code along with this now to get to that point.
I'm going to start with this code, but I'm going to remove almost all of it, because what I want ultimately is I just want a single noise value over time walking along the perimeter of a circle. So the idea of looping inside draw is no longer relevant, so I can take that out. The idea of drawing anything is no longer relevant, so I can take that out. I don't need this translate. What I do need is this idea of calling the noise function in two-dimensional space based on an angle that's incrementing over time around the perimeter of a circle. So now that angle has to be a global variable. That angle, every time through draw, gets incremented by some amount. And when I want to make a GIF loop, I'm going to change that to the percentage thing. So I want to go from 0 all the way to 2 pi, and that's the end of the GIF loop. That closes the loop. But for now, just incrementing it by an arbitrary amount is fine. And if I were to say print line r, let's watch this go. So if I run this, what we're seeing is the noise values. Now, this is looping. You can't tell, but I'm getting the same noise values over and again. Except not really, because 0.1 isn't perfectly divisible by 2 pi. But I'm not going to worry about that. David Snyder actually pointed out that if I use the radiance function, like 360 divides into 1 perfectly. So I could
TMC writes 3 versus 5 in recording. Oh yes, thank you.
A perfect loop. Thank you for that suggestion. So now what I need to do is map those noise values to something. So I could do color, I could do position, I could do size. Let's have it do position. I think that's kind of a very literal way of looking at it. So I'm going to now say x equals map r, which has a range between 0 and 1, so 0 and width. I'm going to use the circle function because it's my favorite function. X comma height divided by 2, 100, and now I'm going to do this. And you can see this looks like randomness, right? This looks like randomness. This looks like smooth randomness, Perlin noise, but it is a repeating pattern. Hard to see that repeating pattern, but it is there. So now what I want to do, if I go back to my GIF loop code, and this is from a previous coding challenge, they're all kind of interconnected at this point. What I want to do now is take this idea.
Okay. Hold on, I need to get that GIF loop code now. It's polar noise blob. Oh, right, okay. So just give me a second here. Oh, I gotta fix that. Coding challenges. GIF loop. This is what I need. Close this. Processing is behaving weirdly. Oh. Okay. This is what I want. This is this sketch, and now I want to take this. Oh, just this actually. I want to take this and put it on the desktop. Replace. Okay.
So I need this global variable A to come over here. I need to take all of this, which is previously in draw, and it goes into render my render. I'm going to paste it in here. And then A, the difference is A doesn't increment. A is based on the percentage. So A equals the percentage times 2 pi. Because if you recall from this video was designed, this code example was designed to render frame by frame some looping pattern from 0% up to 100%. And now that I know that my curling noise values will loop as I go from 0 to 2 pi, I can take the percentage of how far am I through 2 pi. So let me run this now, and we can see, there we go. Now, I believe this will be a perfect loop. Let me stop for a second, because this example, I think, isn't very illustrative of the point that I'm trying to make. First of all, it's moving so quickly that you could probably fake the idea of it looping pretty easily, even without a perfect loop. So let me see if I can demonstrate this more clearly. Number one is, let me also, in addition to drawing that circle.
Okay. So this is where I'm going to stop. I will need FFmpeg, the website, up later. I'm going to close. So that much of the video I think is fine. Oh my goodness. Okay, sorry, hold on, let's see. There we go. Oh, I can bring this over much further. Like here. Okay. All right, I'm going to get to the interesting part in a second. What would hopefully be the interesting part? Let me close this. This I can have, whoops, open. Really, is there no window? Oh yeah, okay. Let me bring that over here. Let me go to FFmpeg. And also to here. Okay. Now what I want is okay. Then the other thing I probably could use is okay, sorry everybody, if you're paying attention. And we do a quick roll call. Anybody watching, say hello in the Slack channel, in live, or if you are a YouTube member who does not somehow, for whatever reason, have a Slack invite, please say hello in the YouTube chat. And I'm going to get started with doing some kind of goofy. Now here's the question. I'm going to get started with doing some kind of goofy fast forward through time shtick and redo the rest of this video. And I am going to erase this because I might want to do a diagram. Okay. Hello, David, and hello, TMC. All right. This is like olden times when there were just like a few people watching the live streams. Okay. Oh, and the OXD8. That's a name that I don't recognize. Theo Thomas Wolf. Okay. Welcome. My middle name, little known fact, maybe not little known fact, middle. Okay, that's interesting. Weirdly, I returned with no sound. Okay, but I'm back. Hold on, I'm logging into my Twitter. Hold on, I need, Twitter. Okay. Okay, 932-289. So what I'm doing right now that I'm not having you see is I'm going to my direct messages with Etienne, just to see if there's anything here I want to mention. Okay. Okay. I'm just trying to think. Okay. I guess I'm not gonna. I was gonna screenshot one of Etienne's messages and show it, but I think there's nothing. It's just sort of more like a friendly chat. So, all right, I better get going here. I'm recording to disk. So, two things I want to mention. One is Mathieu and I would really like to figure out a way to record just the. I might as well do this right now. Boy, I can't finish a sentence today. Mathieu and I would like to figure out a way to record the green screen separately, and which will allow us a lot more possibilities in editing things together later after the fact. But there's not an easy way to do that with Open Broadcast Studio. I would have to get like additional hardware probably to just put the feed into something else. Although my fantasy, let me just try this. I assume there's no way this will work. But could I get like a separate like if I do new movie recording, okay, let's say, and then select one of these. Yeah, it won't. QuickTime can't access the camera if OBS is using the camera. So that won't work. But I do have an idea of taking the output out of the Blackmagic box into something else. Anyway, I could, as an experiment today, record the green screen because I can see what I'm doing, but you wouldn't be able to. So I don't think I'm going to do that today. I will just record it as normal, but I am going to, at the very least, do a new screen recording. It'll have to be synced. So click to record maybe I can sync it with a clap. I don't know if I'm getting audio. Let's also get the audio as a backup. Let me delete this. Is it getting audio? Might as well get the microphone. Test, test, test. I don't think that'll mess anything up. Hit record. So now I'm doing a screen recording. And I'm going to hit, that's a good point. So Alka says if you didn't care about the live stream, you could have a 2x1 output stacked left, right, or top, bottom. Green screen on one side, desktop on the other. That's an interesting idea. I think in the interest of time, I'm not going to try to set up anything new right now, but I'm going to give a little clap so that Mathieu can sync this up if he needs to. So at a minimum, I at least have a full resolution recording of the desktop without me. So that allows for some additional possibilities. Okay. And why I'm looking at my email, I have no idea. Okay. I do need this marker. Is this a good marker? Yep. All right. I want to do some kind of crazy Captain Disillusion shtick where I arrive on a spaceship to interrupt. That's never going to happen. But we will. What I will do. Oh, interesting. YouTubers who play games with webcam, for instance, would have the game completely clean and then cam and other live assets on the side, then later composite them. Okay, that's useful to know. That's something I could try. And what I'm going to do now is, what was I doing? Oh, right. But I am going to just briefly do this. Let's see, can I transition it? Can I do? All right, hold on a second. Give me a second. I would like to try some weird shtick. Turn the chroma key off. No. Okay. Chroma keying is off. And now, can I use a hotkey to enable chroma keying? Can I do a filter with a hotkey? This is definitely what I should be spending my time on. How can I quickly enable and disable a filter? Because I would like to make the transition from here to here seamlessly. This is really ridiculous what I'm doing here. Filters, fade. Oh, the next update, so that doesn't have it. All right, that's fine. So we'll just do it with a transition. Okay, I should really script this out in advance, but wow, this really looks like the worst chroma keying ever. Wow, it's like horrifically bad. I didn't realize it's kind of amazing that it works at all. Look at that horrific shadow. Like all the way over here. And like how bad the shadow is like this. Why? I turned all the lights on. Is it always that bad? Yeah, amazingly, it's fine. Okay, well. C'est la vie. All right. Okay, here we go. Stop. This video, no, that's okay. So improvising is not a skill that I have. Although you think. Stop. I have arrived from the future. Through almost like, how many days? Wednesday, Thursday, Friday, Saturday, Sunday, Monday, 6 days later. Wednesday to Thursday to Friday to Saturday to Sunday to Monday. 5 days later. Okay. Stop. It is me from the future 5 days later. I have been thinking about this all night, all day. I haven't slept. I'm very stressed out. What I did in the live stream, which you are now watching an edited version of, I went down a road which I don't think really made the sort of looping idea terribly clear. I'm going to try this one more time. Did you not have a light behind the camera before? All right, let me try this one more time. Stop. Hi. I haven't slept in like 5 days. That's not really true. I've been sleeping fine. But I've been obsessed with this. And I recorded this video during a live stream. And I had some messages with Etienne, who's the inspiration behind a lot of the ideas in this video. And I realized, wait a second. There is a better way than what I am about to do that you're watching right now to demonstrate the idea. So let me bring my computers back and let me transition to here. No, to here. Oh, crap. One more time. It doesn't actually make sense for me to, that'll have to be an edit point. So I'm not going to try to like click. Oh my God, where have I gone? Green only, there we go. All right, one more try. All right. I feel like the ukulele could be useful for this. It's the polar to Cartesian coordinate song. No, let me just get a move on here. So I better cycle these cameras. Ooh, the next version releases today. That's exciting to know. All right. Oh. I think I have a better idea. Excuse me. Hold on. Stop. Hi. So 5 days have passed since I was back talking about this noise looping thing. And yeah, I could go on in the previous, than what you're watching right now. And you can go, I'll link to the live stream where this continues. But I don't think I really got it. So I'm back. I had some advice from Etienne. Thank you again, Etienne. The inspiration behind a lot of the ideas for looping noise. And I think there's a better way to demonstrate what's happening. And so I'm gonna come back to my computer, and one more time. I think I've got it now. I've got it now. Hi, sorry to interrupt. Oh, sorry, everything okay? Okay. Hi. Sorry. I know I'm interrupting. You were on a roll there. You're going to loop the noise. It was going to be great. It wasn't great. I'm here. It's been about 5 days, and I've been thinking about this constantly. What is a better way to demonstrate what I'm trying to demonstrate here, looping a chaotic scene with noise? And thank you to Etienne, once again, who came in with some nice advice, with some messages to me over the weekend. And so what I'd like to do is now, you can go and watch what I did before if you want to click over to the live stream. I'll link to that in the time code video description magic thing. But I'm actually going to continue and do it in a different way from what I did before in this video from the future, although it's present for me now. That was the past. Okay, that'll have to do. And I'm going to go back to here. First of all, I'm going to hit stop recording and then start recording again because I'm worried about it crashing. And I'm going to turn on the, whoops. I'm going to turn on the chroma key. And I'm going to go back into processing. And here we are. All right, 3 o'clock. Sorry, I have some text messages. Let me just check these. All right. It's kind of actually somewhat related. We just gave away, we have this huge collection of Thomas trains that my kids love to play with. This is the text message I'm getting. They don't play with them anymore. And we probably spent over years buying all these like hundreds of dollars, but we just sold them to someone in the neighborhood for $50. So yay! Dinner on me for me, not you, because I don't know. All right, oops, I lost our chat. No, here it is. Okay. So actually, I'm sorry, I'm just getting something from, there's an example from the Nature of Code, I think, which is noise walk. Noise walk, not many. Random walk noise. Am I really going to rewrite this? No, okay, I'm not going to refer to this, it's fine. Okay, all right. I'm so excited to pick off from where I last left off here in the code. I've got a circle moving chaotically along the x-axis according to the results of the noise function, which makes a perfect loop as I pass in the 2D. I don't know if I need to explain that whole thing again. Okay, I'm excited to be back here with the code. Now, what I want to talk about, I think the way that's going to make this interesting, and let me go over to the whiteboard here. That's no whiteboard. This cable again. Oh, got it. There we go. Ugh. How many things can go wrong? Okay. All right. I'm back and really excited to dive into this code again. So one of the ways I think that will demonstrate the idea of looping more effectively is to have multiple looping noise values, right? Currently, I just have this one noise value. I'm getting it from the path, the circular path in the noise space, and I'm assigning that value to the x location of the circle. And certainly, if I were to also say, well, take that value and assign it to map it from 0 to height and assign it to y, what's going to happen? Well, this is not that interesting. If x equals y, it's just moving along the diagonal path. What I want is to have multiple different values of noise for different parameters of the system. And then I could make like lots of things moving all around. This is gonna make some exciting stuff happen. So let me first talk, how would I do that? So in the case of noise in one dimension, what I've done previously is I've just taken different parts of the noise space. Like, let me look at the noise values between here and here. And these noise values I'll use for the x value. And then I'll take the values between here and here, and I'll look at these values for the y values. But these won't be loops. So there's two approaches I could take. I can't decide which one I want to do. But if I'm thinking about two-dimensional noise space, right? And this is, by the way, going on to sort of theoretically forever and ever. I could take the noise values along this path, and the noise values along this path, or one down here. So I could just look at a circular path from somewhere else within the noise space to have different random chaotic values that are looping. I don't know why I keep saying chaotic, but whatever. To have different random values that are looping. To have different noise. I could look anywhere within this noise, in this two-dimensional space, to have a new set of noise values that are looping. There's another way I could approach this, is I could always take the noise value from the beginning chunk, but have a different seed value. So that could work. But I think actually I want to do it looking at different places. So come back with me. And I think a nice way to do this would actually be create a noise loop class, right? So I could make different like noise loop objects that just pick a random spot and give me those loops. So what I'm going to do is I'm going to create a new tab. I'm going to call it noise loop. I'm going to call this class noise loop. And what does each noise loop need? Hold on. What's a spaceship? That's a spaceship. You got it right the first cut. I don't know what anyone's talking about. I'm going to create a class called noise loop. And let's think about what the noise loop needs. Now, it certainly needs this variable. I'm calling it noise max, but what this variable actually is, it refers to the radius of this circle, right? So that I think of it kind of as like the spread. I'm taking the noise values I'm taking the results of the sine and cosine function and mapping them. I'm giving myself way too much leeway here for the editing. Let me just come back. I'm just going to go back to Mathieu is like, if it's not very many, if it's simple edits, I'll be able to do it tonight. No, I'm sorry that I haven't made it very simple. Okay. Right, because this is really, if it goes between -1 and 1, that's really, I'm mapping it between, it's really the diameter. So it's not really the radius, right? It's really this value is kind of like the diameter. Oh, I'm in the wrong thing. This value is like the diameter, right? Because I'm going from -1 to 1. Okay. Thank you. Yeah, sorry, your comments come in so much later than when they actually happen, so that's why I get confused. All right, I'm going to write a class called noise loop. And the core idea of this class is first I need a constructor. the core idea of this class is for me to write a function, I'll just call it value, that returns the noise value. So whenever and maybe I give it, I want a value at a given angle. No, I'm thinking too far ahead. Hold on a second. Oh, I'm really losing my mind here. Hold on a second. Let me just look at the code I wrote the other day. Let me retweet this tweet from Kay Weekman. Because it's in my GitHub. Oh, I'm probably logged in here. Let me just see what I did. Oh, I'm not signed in. Let me just look at it over here. And I'm not signed in. Whatever. One more try. I prefer, all right. Let me look at I'm going to write a class called noise loop. And the idea of this class that anytime I create a new noise loop, I'm going to get a set of noise values along a circular path. And they're going to be different circular paths. So what do I need? First, I need a constructor. And what are the parameters? What are the variables inside of a noise loop? Well, one of them is this noise max parameter, which actually, another way to think about it is the diameter. It's really like the size, the spread. I like to think of it as like the spread. Like, is this a small circle where I'm going to have lots and lots of really similar values, so it'll be it'll be smoother, or do I have a really, really large circle? So that's kind of key. So that's the thing I'm going to want to set. So I'm going to want to say, I could call it spread, let's call it diameter. And I could say this dot diameter equals diameter. And maybe I should call it like noise diameter. Oh, and I need to declare it. I'm forgetting about Java. I need to declare that up here. So we can call that diameter. And so the idea here is that I'm going to say, I'm going to have a noise loop called X. I'll call it X noise. And X noise is a new noise loop with a diameter of 5. And then somehow here, what I want to do, all of this stuff, I don't want to do this here. What I want to do is I just want to say float X equals X noise dot value at a given angle. So I probably want to, I'm thinking I'm going to have a function called value. Maybe it should be just called noise. I don't know what it should be called. But let's call it value, which basically what it does with a given angle is it does exactly this. So now if I go back into the class and I write this function value that returns a float and receives an angle, the idea here is that I need to calculate the x offset and the y offset. I called it angle now. Let's just call it A right here. So it's the same. This is now called diameter. And why is that not picking it up? Diameter. I got to spell it the same way in every place. And then I need to say return R. So if I did that, now what I would actually like, this was in here. The loop, I think I'd like to define what kind of values I want in the noise loop object should keep track of that. So Perlin noise, right? I could just say return R. But this is always going to give me a value between 0 and 1. But what if I ask the user to say, give me a minimum and a maximum that you want, and then I'm going to always return map R between 0 and 1 to between 0 and width. That's pretty simple here, right? So I always want to just return that. Not between 0 and width, between minimum and maximum. These are variables that are part of the object. And then what I want to do is when I create the noise loop, I'm going to say between 0 and width. So I want a noise loop with a diameter of 5, and I want the noisy values to be returned between 0 and width. So now, I could just recreate what I did. Like I'm going to now, actually, let's make a Y noise object. So now I'm going to have two of them. X noise, a Y noise loop between 0 and height. I'm going to do a Y noise object. Ooh, this is very exciting. Y noise object. I'm going to get both of those values, and I'm going to run it, and it's still moving along the diagonal. Why? Because I haven't done that offset. So even though I have two separate noise loop objects, they are both walking along the perimeter of the same exact circle in the noise space. So I need some other variable to give me a random spot, a center spot, so to speak. And so we can call that, I could just move only along like one axis, but why not just pick something random throughout the entire 2D space? So what I'm going to do is, in the noise object, I'm going to say, I'm just give it like an X and a Y as a center. I don't want to call it X offset and Y offset, because that's what I'm calculating here. Let's call it CX and CY to indicate center. And I'm going to say CX equals random. I don't know what a reasonable range would be, but let's give myself a range between 0 and 1 million. CY, the same. And then here now, what I'm looking to do is I still want the values to be oscillating around the perimeter to be moving around the perimeter of the circle, but instead of my spread, my circle, this with 0 to let me go back and say that again. Where do I add CX and CY in? Well, clearly that needs to enter in here somewhere. And you might think, do I adjust this? Am I adjusting the angle? No, it's actually these parameters that I'm adjusting, because what this really defines is, and I didn't draw this super accurately, but basically, if this is 0, and this is the diameter, and this is the diameter, the circle that I'm getting is this. So what I want to do in this center point, what I really want to do, I don't know if it's really the center point. It's more like offsetting the corner. So it's really, I'm looking at a box between 0 and diameter, and then walking along that perimeter. So all I need is an offset for this box somewhere along the X and somewhere along the Y. And the map function will take care of that for me. So I can just say, I want to look at CX plus diameter, and CY plus diameter. Okay, so this should now give me this. Great. So now I am getting different noise values for the X and the Y, and I've also encapsulated this nicely that I can do things like, let's just change the diameter value to 2. Let me give myself 200. Shoot. I didn't mean to stop that. Did I do that on purpose? Screen capture 1. I don't know why that just happened. What's the lack of E notation? Nathan writes, the lack of E notation is disturbing. Yeah, I'm going to resync. I don't know why. I don't know that we're going to need to use this. This is just especially because the turnaround is going to be like this if I want to release this tomorrow. I'll give it another clap. I don't know if that was good enough. Okay, 2 claps. Oh, 1 E6 for 1 million. That will work. I had a little technical hiccup there while recording, but I did get a nice message from the chat that I can use this notation, 1E6, as a shorthand way of writing 1 million. Okay, actually, hold on. I don't know if I want to mention that. Where was I? Forgot what I just did last. I'm also going to, just because I'm afraid of crashing, I'm going to start and stop this recording. All right. I was about to change to 240 frames. That's right. Let me just go back to here. I can also change, like I could also have 240 frames. I mean, this is for making a GIF loop. So I have 240 frames and you're going to see it sort of like happening over many more frames. So this now is a perfect loop. But let's make this even more exciting somehow. So one thing that I think could really help here is what if I make yet another class? I'm going to call this a particle. And the idea of a particle is that it has all of this stuff. So it has two noise loops and a particle constructor. And in the particle's constructor, it makes those two noise loops. And then it has like a render function. I don't know why I have this begin shape in here. It has a render function. And in the render function, I draw this circle, and let's make it, kind of pink with some alpha, maybe with no stroke. Maybe the size is smaller, and then I'm also going to need to get the angle passed into the render function, and this has to say void render. Why am I doing this? I'm doing this because now I could say particles is a new array of, let's say 100 of these. Let's make the window a little bit bigger. And then in setup, I'm going to go iterate over all of the particles. Typing is hard. Particles, index I, and I'm going to make a new particle. And then I am also here going to say for every particle P in particles, P.render with that angle. Now, there we go. Look at this. So now I have a whole bunch of them moving chaotically. Okay, stop. Wait, I'll just do a few more things here. I am going to say, first of all, let's make them a little brighter. Let's add a noise loop for the size. That's the particle's diameter. I'll call it dnoise. Let's add a noise loop for like red values, red, green, and blue values. So I'm going to make some more noise value, more looping noise values. Like dnoise is a new noise loop, also with 2, but I want the diameters of these circles to go from 0 to 10 to 60. And then this is going to be for color. So the range is from 0 to 255. And B noise is for blue, 0 to 255. And let's make sure it stays somewhat bright. Let's give them a larger space to work with. Actually, since I have so many of them, I don't mind if they leave the window. So I'm going to go negative width plus to width times 2 and negative height to height times 2. That might be a bad idea. And then now I'm going to get some more things. Like I'm going to have a diameter, which is the D noise. I'm going to get a R and a B, which is from these other noise loops. And let me get this fill. This fill now should be down here. And I'm going to say R. Maybe I'll just give that 50, B. And now let's run this. Whoa, it's going really crazy. So why? All right, sorry. Why is it going so crazy? Well, I think my diameter values are kind of large. So let's move, let's now, especially because the space is so big. So let me do that. Whoa, that is weird. They're doing something real. I have a mistake somewhere. This doesn't look right at all. Hold on. So weird. What is going on? Am I just like too way out of the zone? Like the Perlin noise space is not that big? Oh yeah. Okay, I think that's what happened there. Yeah. No, Nathan, noise gives values between 0 and 1. I mean, Perlin noise, the actual algorithm, gives values between -1 and 1, but in processing, the implementation just gives you values between 0 and 1. Pretty sure about that. Okay. All right, so I was a little bit, I think, overly ambitious to like pick this very large space by where I would place these little noise circles. And I think it's given me some weird results. So I'm going to shrink this. I think a random number somewhere between 0 and 1,000 is perfectly reasonable. And so with that, let me run this again. And we can start to see, here we go. This is what I'm looking for. So this looks like a bunch of particles moving smoothly. I can have their colors change. Perhaps their colors should change more rapidly, and maybe their size should also be, and I can have them move a little bit faster. So we can see this. Again, I want to stop myself from trying to be artistic because, as you know, it's not something that I'm capable of doing. What I want to is just show you the technique. This, I think, certainly has the appearance. Maybe you can see the loop. Can you see the loop? It's hard. I don't know. I'm losing my mind here staring at this. It's like looking at those 3D pictures. Do you see it or not? But what's magical about this is how I have a lot of different values looping, so I can now render a GIF where all sorts of parameters are changing. And if you have some other design that is your own creative design, then you can now apply this technique. So let's turn this, if you remember, I started with my processing GIF loop challenge code, which just had a rotating square. So I still have that base code there. I can still turn on recording to true. I can run this, and so it's going to record all 240 of those frames. All right. Alka says I can see things looping. That distracted me. If you'll indulge me for a second, actually, let me make the total frames 360 and make the noise loops a little bit wider. So to like reduce the chance that you're going to visually see the loop. And now I'm going to record, let me go back. I shouldn't be messing with this. I should just do what I do. Let me indulge me for just a little bit longer. I'm going to make the noise loop a bit wider and I'm going to make these change, and then I'm going to give myself more frames to work with. Let's actually just double it to 480 frames, and now this should give me a scene here. Okay, so I'm going to look at this. You might be able to see a looping pattern happening. I cannot detect it, but that's not the point. The point is the creative possibilities that you will make from watching this. Let me close this. Now, if you recall, this is based on the code from my GIF loop processing challenge. And all I have to do now is change record from false to true. This will trigger this saving to the output directory. And I'm going to run it now, and I have to wait. Waiting, it's recording, it's doing something. It's got to do 480 frames. Speed this up a little bit. Okay, it finished rendering all 480 frames. I can go here and see there's an output directory, and I can look at all of these frames. Sorry. I can, let me. It finished recording. I can go to the output directory, and I can see there are all of the frames. There should be 479, up to there are 480 total. This will stop at, I don't need to go all the way in. What is wrong with me today? All right, it finished. Let's go check to make sure it actually recorded. If I go here, there's an output directory, and all of the GIF, all the image files that I've saved are in that directory. There's 480 of them. So now if I render those to a GIF, it'll make a loop. Now, in the previous time I did this, I used a website, easygif.com, which was a nice technique for just finding a website, dragging your files, and having it create the GIF. There are plenty of other ways to do it, and one of the ways I want to demonstrate right now is using, And one of the ways I want to demonstrate that right now is using something called FFmpeg. FFmpeg is a complete cross-platform solution to record, convert, and stream audio and video. I'm happy to do a video or a tutorial about how to install FFmpeg, but I already have it installed on this computer. And what I can do, this is an application that I can run via the console. So I'm going to go over here to the console. You can see I am in the processing sketch. There is an output directory, and I can say, I don't know FFmpeg, but let's see if I can figure this out. The command, I definitely start by saying FFmpeg. Then maybe I do -I. I have to look this up. I'm going to go back, scroll through the chat history. There it is. It's not -I, it's -F, maybe for format. I actually don't know. Read the FFmpeg documentation. Image 2, I'm looking dash frame rate. My frame rate, I think I'm going to do 20. I'll just do 30 frames per second for this GIF. And then -I. Now this is the names of the files. So everything is in a directory called output. And then all the files are named and numbered. So what I can do is I can say %0D3? No, %3D. Because basically I'm saying it's GIF-3 digits and then .png. And then I need to give it the file name that I want, which I'll just call noiseloop.gif. I think I got that right. And now if I hit enter, I say my little FFmpeg prayer. And I hit enter, it is doing something, it finished. I can go back to the Finder, and way at the bottom of this directory, nope. Oh no, it's right here, noise loop GIF. Okay, let's take a look at this. Hey, animate. Has it looped yet? I have no idea. That's the point. It's a perfect loop of random noise. Find the loop. This is like a little, it's like, where's Waldo? But Waldo is the moment it loops. So I should say, And I think I would like to do a follow-up about this. I did get some comments on the previous video about whether or not this is actually Perlin noise or not. So there is a long GitHub issue thread that discusses where the algorithm that's in processing itself came from. It's an implementation of Perlin noise from 1983, often referred to as fractal noise or value noise, and is not the current most modern implementation of Perlin noise itself. Etienne uses simplex noise. So this is actually nice territory for somebody to make a processing library that generates noise for you in a variety of different algorithms and different characteristics. And so I might like to come back and do a video that actually looks at different kinds of noise. And there are some oddities in the current noise implementation that's in processing itself where you can sort of detect these peaks and values, so to speak. But I'm pretty excited by this. This is a perfect looping GIF, undetectable to me, with this chaotic scene of particles moving. So I hope that you will join the GIF train. All aboard the gift train, the train of gifts, choo-choo, and make your own. Share it with me. More information, the code for all this and all that sort of stuff will be in this video's description. Let me know what you think. Let me know what you make, and I hope to see you in a future coding challenge. Goodbye. Mwah. All right, I don't know if I kind of feel like I wanted this to move faster, but whatever. All right, let's watch one of them. It's gonna come back to where it started. I don't know, are we good? Am I good? Did I finish all that? Is this something that Mathieu can work with, do you think? Let me know. I just want to refer you to this comment. If anyone wants to jump in and contribute to the discussion, but so I'm going to go here, and I'm going to scroll down and find, let me do my newest first. Oh, there's a lot of comments on this video. Where is it? Where is it? Perlin. Ah, yes, here it is. So this is the comment that maybe I'll come back to this on the live stream on Wednesday. I have said this on several other videos. This is not Perlin noise. This is a form of fractal noise, several layers of smooth noise on different frequencies. Perlin noise is inherently closed. If you set the correct scale, you will automatically get your desired perfect closing loop. This also works for creating Oh, I know what I forgot to say that I wanted to say. And then I didn't link to the GitHub issue thread. Anyway, so if anybody wants to chime in or do some research on this, I've gone down this rabbit hole a bunch of times, and I'm pretty sure that the original implementation, a decision was made not to change the noise algorithm that's in processing because it would change the quality and characteristic of artistic projects that were made with processing, but it would be totally reasonable to make a library that has other implementations of noise that people could use. So I think I would like to explore that. So I wonder if I could even implement Perlin noise itself in a coding challenge, and then that could be the beginnings of a library. We'll see. I don't know about processing, but P5JS doesn't layer noise of different frequencies. So the P5JS implementation is just a port of whatever was in processing, and it was probably ported poorly, because I did it. So it's just generated reproducible noise. Let me find the discussion. Whoa, this is from 1 million years ago. What was this one? Yeah. Could have sworn there was a. I mean, I know there's discussions on. Oh, it's 3:40, so I have to go. I did hit stop recording. Simplex is an open algorithm that reproduces Perlin noise, but isn't the same as that would infringe copyright. Perlin noise is copyrighted? That's why everyone's probably getting bent out of shape about. Ah. So I think the implementation is this 1983 gradient noise. That's what's in processing. Perlin did not apply for patent, but 2001 he was granted patent for use of 3D implementations of simplex noise for texture. Has the same purpose, but uses a simpler space-filling grid. Simplex noise alleviates some of the pattern problems with Perlin's classic noise. Oh. You know what? Let me go back and re-record the end of that video and to discuss this, because I think this Wikipedia page is good. Bent out of shape. All right. I'm gonna hit start recording again here on the here. All right. And here we are, our perfect looping GIF. Now, I want to add a couple things to this video, and I would like to come back and actually make a longer video about this and actually implement a noise algorithm itself. I got some comments on the previous video asking about or discussing whether what's in processing is actually Perlin noise. So this is a very interesting question, and there's a long history of this that goes all the way back to 1983, and I don't claim to be an expert on this, so I need to do some more research, and I would be happily take suggestions in this video. But if I go to the Perlin noise Wikipedia page, you can see here Perlin noise is a type of gradient noise developed by Ken Perlin in 1983. This is maybe sometimes also called fractal noise or value noise, and this 1983 implementation or a version of that is what is in processing. And there have been several GitHub issue threads discussing whether that should be updated. And at some point a decision was made to leave it historically what it has been, not since 1983 because processing was started in 2001, because it would really change the way people's projects that were made in processing look, the sort of artistic quality of them, if the noise implementation was redone. But what Etienne uses for his GIFs is actually simplex noise. And so you can see Ken Perlin has published many different updated versions of the algorithm. I don't know if they're all open source or not open source, but this is something I would like to explore, particularly simplex noise, because one thing you might notice about Perlin noise in processing, or the noise function in processing and P5JS, is there are some strange artifacts. And you can see this, some of the problems with Perlin's classic noise, among them computational complexity and visually significant directional artifacts. So you could make the case here that there are some visually significant directional artifacts. And I do not like directional artifacts. I like non-directional smoothness. Who knows? So I want to come back and revisit this, but I do also want to make one other point, which is that what I'm doing is I'm creating a loop by working in 2 dimensions. I'm looking at Perlin noise in 2 dimensions. But what if I wanted to actually loop in 2 dimensions Perlin noise? Wouldn't I need to go to 3 dimensions, or wouldn't I have to go to 4 dimensions? So that's yet another topic. This could never end, honestly. So someday, keep me honest about this. Remind me, give me your thoughts about this in the comments. I would like to come back and do 2 more videos. I would like to look at other noise algorithms. A great coding train community project could actually be a processing library that allows you to pick and choose from value noise, fractal noise, simplex noise, true Perlin noise, whatever, all these different possibilities. And this would be something that, you know what? I want to do some tutorials about making a processing library. And this could be the library. Oh, this is great. I have a plan now. Coming soon, this week. I'm going to do this. And you're going to give me some feedback and thoughts. But hopefully this is giving you the seeds, the noise seeds to do something interesting, to make your own GIF and have it loop in a magical, wonderful way. Thank you for watching. Mwah! I will see you soon in a future coding challenge. Goodbye. Open simplex would be the open algorithm. Oh. Ah, shoot. Do I dare explain this one more time? Yeah, open, because there is a nice, I know someone made examples. Yeah, and by the way, it says it right here. There have been debates over the accuracy of the implementation of noise in processing. For clarification, it's the implementation of classic Perl noise from 1983 and not the newer simplex noise method from 2001. Do you think I should redo that explanation one more time? Or was that enough? Am I going to get flamed? I mean, I don't think YouTube is full of commenters who are like highly strict about the nuances of noise. Or can I go now? Simplex noise is the patented version. Let me do this again, one more time. I feel like I want to get this right because even though I'm sort of saying I don't know and I need to do more research, but let me try this one more time. Because also the processing reference is a useful, the processing website really needs to be redesigned. Oh, it's the worst. Okay. Yeah, Yeah, I think it's fine. Me, I am, so me says it was fine. Let's leave it at that. It's probably like adding several minutes to the video, but I think this would be really fun to do a how to make your own processing library and how to make your own JavaScript library. And actually, this is like a project that I could do over quite a while because I don't have enough topics to make videos about. Data and APIs, help me, help me. Why did I agree to this? So anyway. Yeah, because there's nothing that would make me happier than to open up Eclipse on a live stream. Yeah, that's happening this Wednesday. After I do the inheritance and polymorphism thing. All right, I'm going to go. I don't know why I'm recording again. Thank you all. So I'm coming back this Wednesday for the regular time. My plan is to do inheritance with ES6 classes. I have this idea to follow up about noise-ish stuff. Maybe Nathan is typing. Maybe Nathan's going to tell me to redo that explanation. And I don't know. Yeah, Eclipse. I know. Won't that be awesome? I was watching Michael Reeves. Is that what I'm thinking of? Does anybody watch Michael Reeves on YouTube? Yeah, Eclipse is my jam. Michael Reeves in a video had Eclipse and Java opening, and it like blew my mind. Michael Reeves, yeah, clearly just used VS Code. I can use VS Code and build like a Java library with VS Code. Is Michael Reeves like, who needs an IDE anyway? All right, I'm going. No one's told me that I have to do that again. It's going to be fine. It'll be slightly wrong. I kind of want to do it one more time. Just, Mathieu, use the first time. That'll be better. But I can't live with myself. Oh, so simplex would be hard to explain. But I can just grab the implementation of it because there's an open... Okay. Stop talking off topic. I'm recording this one more time. And there you have it, my beautiful looping GIF. It brings joy to me. Does it bring joy to you? Otherwise, you're supposed to get rid of it. But I don't know, GIFs. Anyway, Sparkle, is it about bringing Sparkle? I don't recall. Here's the thing. I want to mention one more thing, and hopefully this won't take very long. This video might be now suddenly like 15 minutes longer than it already is. But I want to talk about, because I got some comments on the previous video, discussing whether the noise function in processing itself returns Perlin noise. And it is somewhat accurate that it does not. Now I have to just do it again. And there we have it, our perfect Perlin noise. Don't say Perlin! Okay, Nathan said it was fine. I should stop. I'll just try one more time, just for fun. And there we have it, our perfect, it's ours now. You own it as much as me. Nobody owns it. It's a GIF with pink circles in it. It's our perfect Perlin, don't say Perlin noise loop. The reason why I just said don't say Perlin to myself is there has been quite a long discussion many times over about whether or not the algorithm in processing itself that's implemented in the noise function is actually Perlin noise or not. And this could take a very long time to discuss, and I actually would like to come back and do another video about other noise implementations. But let me refer you briefly, first of all, to the processing page, where you can find written on the documentation site. There have been debates over the accuracy of implementation. I don't think. I think I should just go with what I had before. What is it that I was now? I wasn't happy that I didn't talk about simplex versus open simplex. It's fine. I'm gonna go. I'm gonna go. It's fine. It's fine. It was what it needed to be then. I was trying to make a Marie Kondo joke. I have other stuff I have to do. It's 4 o'clock. I'll just try it one more time. Just one more time. I think it's better actually to just be here. And there it is, our beautiful, perfect, pink, purplish circles noise loop. I'm excited that I've made this, and I hope that it unlocks some ideas for you. Now, there's 2 other things I want to mention about this. Number 1, there has been quite a bit of debate over the years, many GitHub issue threads, some discussion about the documentation. I will link to some of those threads in this video's description about whether or not, about what is the algorithm actually in processing. Is it Perlin noise? Is it not Perlin noise? Is it simplex noise? Well, it's definitely not simplex noise. I can tell you that. But what it is, that historically, Perlin noise is a type of gradient noise. Also, I believe also sometimes referred to as value noise, developed by Ken Perlin in 1983. And the implementation that's in processing that was made in 2001 is based on the 1983 implementation. So it has some strange visual artifacts to it, some funny behavior, and it's not what is commonly known today as simplex noise, the Perlin noise algorithm that has been refined over years. There's also something called open simplex noise, which is the open source version of simplex noise, and you can read a lot more about this on the history. But the decision was, one of the reasons why Perlin noise in processing has stayed at that original implementation is because while some of these newer versions of noise kind of clean up some of the strange directional artifacts and things, like nobody wants directional artifacts in their noise. I mean, come on. But what was I saying? This will be like one of those boop edit things. Is that many projects over the years have been made in processing, And if the noise algorithm were updated or changed, it would change the visual quality, the sort of artistic result of those projects. And it's nice to keep that continuity throughout history. Now, it would really make sense for there to be a processing library and also a corresponding P5JS library that has a variety of different noise implementations in it, some of which have much better computational complexity, because what do we want in our world, in our lives? Computational complexity. And so I think actually I'm starting to think that this would be a nice project for the coding train itself. So maybe I will come back and do some videos about other noise implementations, OpenSimplex, and see if we can create a library for processing that has that built into it. But the other thing I wanted to mention, there's another thing, which is more important actually, which is that I'm limiting myself, and the processing implementation limits you to this as well. It only supports 1, 2, and 3-dimensional Perlin noise. Fractal noise, value noise, whatever noise it is. And to create some of these looping effects, you can imagine, I'm looping kind of one number and I'm using 2-dimensional noise. What if I want to loop within 2 dimensions, but do I need 3 dimensions and then 4 dimensions? Noise can exist. Simplex noise, OpenSimplex noise can exist in multi-dimensional space. So that would be worth coming back to. And that's the kind of technique that Etienne does write about a lot in the blog post that I will also link to in this description. But isn't that amazing that we're today 2093, that's the year, right? Some future. And we're still talking about something that was made in 1983 by Ken Perlin, who incidentally, if I just walked through this, oh no, he moved offices. But he's at NYU, and I'm going to go talk to him. Maybe I can get him to give us the final answer on, is it Perlin noise in processing or not? Although if he's watching this, I'm incredibly embarrassed right now. Okay, goodbye, and I'll see you in a future coding challenge. Obligatory train whistle. I don't know what the no means from TMC. I think probably Mathieu should just use the first version of this. I've got to go. Should I try it one more time? See what you're getting for being a patron / member. Yada, yada, yada. All right. I got to go. See people are typing a few things. All right. This would be good for some outtakes. I'm going to hit stop recording. Oh, oops, no. Oh, let me stop this screen recording because, of course, we're definitely using this. Okay, I'm gonna hit stop streaming. No, I'm not gonna hit stop streaming. Okay, thank you everybody. I definitely have to go. Let me just look at my phone here. All right. Yeah, I'm not sure. So MiAmSimi is writing about the var args. So processing, I still think, is built with Java 8. Maybe that's a thing in Java like 6, as far as I know. But oh boy, this is going to be funny when I decide I'm going to use Eclipse this Wednesday. This is going to be like awesome. Okay, I'm going to hit stop stream. Oh no, I'm going to go. Thank you, everybody. I'm going to hit stop streaming, and I'm going to see you all on Wednesday when I will be back to doing my usual thing. Any last words? You can still say them in the chat. I'll still be looking at the chat. I just have to type back instead of talking. I still see the typing going on. I've really lost my mind here with this, what I did. All right. I'm going. You mean stop streaming.